Behind me are 8 coins, of which one is counterfeit and the other ones are real. If we just have a regular scale, the old ones, you can compare and two groups of coins or individual coins and then find out which one is heavier. For this is not a problem in itself. Actually, I haven't even asked the question yet, but the obvious one might be, oh well, find out which one is counterfeit. But actually there are more conditions than this. So firstly, we have to state if the coin is heavier or lighter. Or sorry, and if we don't know if it's heavier or lighter. And we also have to state what we actually want to find out. Either we can find out which one is the counterfeit coin, or we can try to find out if it's heavier or lighter. And obviously, if we already know if it's heavier or lighter, then finding out if it's heavier or lighter isn't a problem in itself. So there are mainly 3 cases here, where the first one is we want to find which coin is counterfeit, and we know if it's heavier or lighter. The second question is we want to find which coin is, if the counterfeit coin is heavier or lighter. And the third question is we want to find which coin is counterfeit without knowing if it's heavier or lighter. And the question really is, how many weighings, how many times do we have to use the scale to find out the answer to these questions? So for the first one, where we know if it's heavier or lighter, for example, say that it's heavier, how many times do we have to use the scale to find out which coin is counterfeit? Well, for this one, we think from the ground up. If we can only use the scale one time and we know that it's heavier, for example, how many coins can we start with and still always deduce which coin it is? Well, the answer is obviously 3 coins, but because then you weigh the first against the second. If they weigh the same, the third coin is counterfeit, and if one weighs more than the other, then the counterfeit one is the heavier, because we knew that the counterfeit coin was heavier. And so that's with one use of the scale. How many coins can we deduce from if we can use the scale 2 times? Well, here it's kind of the same thing, except because we know that with one weighing we can find out which coin it is from 3. But it doesn't have to be a coin in itself. It can be a group of coins, of course. So with every weighing, we're splitting the amount of coins by 3. So therefore, with 2 weighings, we can deduce 9 coins. Deduce which coin is counterfeit or which coin is heavier out of 9 coins. Because then we do the same thing. We instead visualize maybe instead of 9 coins, we have 3 bags of 3 coins. And with the first weighing, we find out which bag is heavier. And with the second weighing, we find out which coin inside that bag is heavier. And if we're allowed to use 3 weighings, then of course we can have 3 bags of 3 bags of 3 coins, meaning 27 coins, and so forth. So that is the obvious answer to the first question is, if we know that it's heavier or lighter, then we just need to use the scale twice to find out which coin it is. And for the second question, if we don't know if it's heavier or lighter, we just want to find out if which one it is. No, sorry, not which coin it is, but if it's heavier or lighter, the counterfeit coin. We don't really care about which coin it is, just want to know if it's heavier or lighter. And for this one, we do kind of the same thing, not really. So we start by weighing these 3 against these 3. And there, okay, so the first case is that they weigh the same, meaning that the counterfeit coin is here, and therefore we know that these ones are real. And then we just compare these three against these three. And since we know that these three are real, then if this one is heavier, then the counterfeit coin is heavier, and if this one is lighter, then the counterfeit coin is lighter. And so now we go back and to the first weighing, and if they don't weigh the same, then we know that this thing is real. So therefore we can again compare this to that. And then, okay, so say that this one was heavier than that, then if these two weigh the same, that means that this one holds the counterfeit coin and is heavier. And if this one weighs less than that one, then, well, yeah, if this one weighs differently from that one, then we know if it's heavier, then the counterfeit coin is heavier, because we know that these three are real. So that's the second case. And then the third case is a bit more complicated. So here we want to know which coin is counterfeit without knowing if it's heavier or lighter. So yeah, yes, I'm back. So how do you do this? Well, we start in the same manner. So we compare these three against these three. If they weigh the same, then we know that the counterfeit coin is here, and if they don't, and then these three are all real, and if they don't weigh the same, then we know that these three are real. So in the first case, where they weigh the same, then we actually do the same thing as we did before. We compare these three to these three, regardless of what happens. And from the last case, what did that tell us? This procedure told us if the counterfeit coin was heavier or lighter, and it also tells us which group of three it's in. So therefore, from this one, we know that in one of these groups of three, there is one coin, and we know if it's heavier or lighter. And this is then we're just back to the first case where we had three, and we know that we can deduce that in just one choice. So you see, like the scaffolding, everything just builds up. This is the beauty of mathematics, in my opinion. So yeah, as we saw, the third case was just a combination of the previous two, but that also meant that it required one more weighing. And I am about 99% sure that I'm right. If I'm wrong, I would be very happy to see some comments saying that I am, and showing me why that is, of course, not just saying no. And so yeah, that was basically everything for me. I hope you enjoyed the video, and see you some other time. Bye bye.